I'll be speaking on routing like it's 1999. My name is Singh. I'm an organizer here at TorontoJS. We also have another organizer, Matt. He probably let you in downstairs. Is he back up here now? No, he's still downstairs. So later on, I'll embarrassingly point him out, and we can all say hello, Matt, to further embarrass him. As I mentioned, I'm the Chief Talking Officer at my company, HoodQ. We are hiring all positions, front-end JavaScript. It's all React, Flux, Webpack on the front end. Very cool stuff. We've been using this tech stack since around October 2014, and we actually created a Flux toolkit called Griffin.js before really any sort of Flux standard was available. I mean, these days you'd probably just use Redux, which Yuri's going to be talking about, but back then Redux wasn't around. Redux only came out in July 2015, so we've been using a whole other Flux toolkit since 2014. Recently, I've actually open sourced that on my GitHub, so if you go to github.com/TazSingh, you can check that out as well. We're also hiring server-side positions for JRuby on Rails backed by Postgres. So if you're interested in that at all, you can come talk to me afterwards as well. But let's start talking about my journey with routing. And well, it all started last year in the year 2015. I was building a React and Flux app with all of the latest libraries. And these days, whenever I start an application, I think to myself, how can I make this as simple as possible? I mean, a team of developers is going to be using this. If they're tripping up over any small thing, that's an inefficiency amongst my team. I want to make it as simple and as direct as possible. So how can I do that? How can I make an architecture that's easy to understand by my colleagues? And how can I improve on existing architectures in order to leverage existing tools and libraries to do so? So unfortunately, I can't demo the app that I built back then because it's closed source, but we'll use another example app, which is a blog, for the purpose of this talk. So last year, I had an application structure that might look something like this. I have my root directory, /. Inside that directory, I have another directory called components, another directory called stores, another directory called actions, another directory called styles. And inside my components directory, let's say, I have a bunch of different components. I have, let's say, a home component, a component for all of my different posts of my blog. I have a component for a single post of my blog, and a component telling you about the blog itself. So this is the same project structure that I've been using for a while now, and I'm sure it's probably similar to the project structure that a lot of you have been using at work or just in general. But why are we using this project structure? Where did this even come from? I mean, I'm not sure how long you guys have been doing development for, but I asked myself this question. How come all of these files are grouped by like the type of file? Like all my components are grouped with each other, all of my stores are grouped with each other, all of my actions and all of my styles are all grouped with each other. That doesn't make a whole lot of sense to me. I mean, what does my about component have to do with my post component? Not very much. Why aren't my post component grouped together? Like all of these questions I had, and they weren't quite answered. What if I have 100 components? Is my components directory now going to be massive? And well, the answer is yes to that, unfortunately. So how did we do this before? How did we do this in, let's say, 1999? And well, why did I choose the year 1999? It's a pretty damn cool year, in fact. A lot of things happened that year. For example, the movie The Matrix came out. It's one of my favorite movies of all time. And you'd already know that, of course, if you attended our hack night on Tuesday where I mentioned that. But anyway, something else came out. An online music app called Napster came out in 1999. And it was released by this guy called Justin Timberlake, seen here in negotiations with the music industry. Something else that came out that year was Bran Stark. He was actually born that year, and here we can see he has my favorite character, Hodor's back. So 1999, all around, pretty damn cool year. But more importantly, how did we actually make web apps in 1999? What was the state of web development back then? Well, back then it's what we called Web 1.0, and things were relatively static. Web servers basically served out HTML files. And we had so little JavaScript and CSS that they were usually just in line with those same HTML files. So basically, all you had to do was serve out an HTML file. Our routing structure for my blog might look something like this, where on the left-hand side, you'll see the URL. On the right-hand side, you'll see the file and the path of the file. So for my root route, we have an index.html file in my root directory. For posts route, I have a posts directory, an index.html file in there. For a single post, I'll have a post directory, a directory called that single post's URL, and then an index.html file in there. And for my about route, it's something similar again, about directory, index.html file in there. So that's pretty interesting. That's drastically different than the project structure that I had in 2015. Here things are grouped semantically by the URL. They aren't grouped by the type of file. So that's interesting. Why did we diverge from that? Like, how come we went from this project structure to what we had in 2015? So to answer that question, let's fast forward a few years to 2004, when Web 2.0 was gaining momentum. I mean, two's better than one, right? I mean, this is probably a way better year than 1999. And it was a major change for the web. Quite a few of the design requirements for the web changed. So in the context of my blog, most importantly, it was the ability to change posts without having to manually edit HTML. So in the Web 1.0 days, if I wanted to add another post, I'd have to add another HTML file. Right? That's a bit of a pain. If I wanted to change the styles of how my posts look, I have to change each and every HTML file. That's a pain. That's not what I wanted at all. I wanted the ability to change these without having to edit my HTML files. And because of that, we introduced database-backed web applications, so persistent data, where I could basically save a post in my database and then use some sort of templating language to then display the HTML based on that post. Something else that's very important was user authorization. I mean, I don't want all of you guys editing my posts. Only I want to edit my posts. So user authentication, user authorization was a big deal in the Web 2.0 days, and it wasn't seen prior to that. So to provide some consistency throughout all of this, REST was also gaining momentum, representational state transfer, and basically what that is a consistent way to represent changing resources amongst web applications. I'll get into that a bit more in a little bit. So most importantly, what did my project structure look like at that time? It could look something like this. Let's say I'm using PHP. So this is quite similar to what we've seen before. I have a root route. I have an index.php file. I have a post route. I have a post directory index.php file, about route, about directory index.php file. So that's quite similar to what we had before, file system-based routing. But when we start to get into REST, into actually editing these posts, creating posts, deleting posts, how does that change? So here we can see the HTTP verb on the far left side, get, post, patch, delete. In the middle are the URLs, and on the far right-hand side are the files that they're mapping to. And for the first time, we can see that there's not really a clear mapping between the URL and the file. I mean, it's a bit different. We can also see that a few of these URLs are the same. The only thing that's different is the file that it's going to, but more importantly, the HTTP verb. That's what external consumers of your web application are going to be using. They're going to be referencing your application by the URL and the HTTP verb. And we can see that a few of the URLs are the same, while previously they were all unique. So there isn't really a direct mapping anymore from the URL to the file. How did we get around that in the Web 2.0 days? So we had something called a htaccess file. And who here has no idea what that is? Put up your hand. Okay, a few of you. I'm very jealous that you have not felt that pain of htaccess files. It was a real pain. But the main point of the htaccess file in this context was to rewrite your URL pattern to point to the file that it's going to. So we basically had to have htaccess files to rewrite that URL to point to the proper file, and that's how we did our mapping back in those days. htaccess files also handled authorization authentication. You could do this via htpassword files, which were also equally a pain in the ass. It also handled cache control. You could also do custom error pages. So let's say you wanted to handle a 404 error differently in one part of your app and in a different part of your app. You could do that with htaccess files. All of these things you could do with htaccess. But there were problems, as I alluded to earlier. you essentially need one of these things in every one of your directories, right? So now your routing map is spread out literally all across your application. That's a pain for a team to work with. It's an entirely different syntax than the rest of your application. I mean, if you're coding in, let's say, PHP, these are in Apache web configuration syntax. So that's not PHP, and it's an entirely different syntax for you to deal with. You have to mentally map the URL to the file, and maybe this is okay if things were consistent, but the problem is there's no conventions across projects. I mean, the file system structure that you're using in one project might be vastly different than what you're using in another project. If you're trying to commit to open source, good luck with that as well. I mean, it could be entirely different once again. And the thing that annoyed me personally, some people might see this as a pro, some people might see this as a con, it annoys me, is that all of these files, .htaccess and .htpassword, are hidden on a Nix-based file system. So it starts with a dot, that means it's hidden by default. So you have to go out of your way to look at them, and that could be confusing for a team working on this, where it's not exactly obvious how things are getting mapped. It just makes the developer do more work. So how can we improve on this? This was a real pain. How can we improve on this? And well, let's fast forward a few years once again to 2007 when Rails 1.2 came out. It was awesome. So much better. And amongst many features in Rails 1.2, the one that pertains to this talk is being able to define RESTful web resources in a conventional fashion. So back in 2007, we might have a router that looks like this. Yes, that is actual Rails 1.2, and yes, that is Ruby 1.8. So it's nothing like what you do today, but it's what you do back then. And what we can see is our router can connect the root route to the home controller index action, the about route to the about controller index action, and we have this map.resources for posts. So that will set up all of our RESTful routes for our posts. It's much cleaner than having htaccess files scattered across our entire application, and you can start to imagine how we can build upon this router to build out a full application. So what did our routing table look like now? Well, relatively similar to htaccess. We have relatively the same result, but just a different way of getting there, where our routes now map to controller actions. And our RESTful part of our app is, again, basically the same result, but just a different way of getting there, where our routes all map to different controller actions. So what are the benefits of this approach? Well, Rails is famous for convention over configuration. And that's what this is really nailing. I mean, all you have to do is type in map.resources and whatever resource you want to set up. And Rails will set up all of the different routes for you. Rails will basically wire up all those different controllers for you. Rails will even go as far as generating all that code for you. So all you have to do is just tweak it from there. That is highly conventional and very good for teams. So as I mentioned, it's very easy to add more RESTful resources. All of your routing configuration is in one place. It's not scattered across your application. It's in this one router, which was fantastic. All of your configuration is in Ruby. You don't have to remember a whole different syntax for writing routes. It's all just Ruby. But there are problems as well. One of the problems is that this is kind of optimized for changing your routes. It's very easy to edit that router, but not have to edit any of your controllers or actions or views or anything, and remap your routing structure to the same controllers. But honestly, how often are you changing your URL structures? I mean, it's not really a good web practice to constantly change your URLs on your users. I mean, that's a bit of a pain in the ass for users. So why is our router kind of optimized to do that? You still have to mentally map these URLs to your controllers. I mean, there's no real benefit on top of that. There's routing logic duplication. I mean, in practice, I found myself doing map.resources posts, creating a post controller. Map.resources users, creating a users controller. Map.resources comments, creating a comments controller. I mean, like, I'm repeating myself quite a bit, even just saying that. And what I found in practice was ended up repeating myself quite a bit. However, it is important for the RESTful structure where we're sharing URLs based on different HTTP verbs. Rails has a flat directory structure. So this is really where our flat directory structure came from, was the Rails days, where Rails has app controllers, app views, app models, and app controllers will group all of your controllers, app models will group all your models, and app views will group all your views. So if you have 100 controllers, they're all sitting in app controllers. If you have 100 views, so on and so forth. So this is really where that flat directory structure came from, and it was there to necessitate, it was there for the need of having RESTful resources, of having all of these different URLs pointing to a controller. So where does that leave us today? It's a great history lesson, but how does that apply to me in 2016? Well, let's go back to 2015 and take a look at the state of web applications in 2015. So the major change is that web applications today are much more interactive than they were in the past. We've seen a rise of front-end JavaScript web applications because of this, because things are much more interactive. I mean, we're creating highly dynamic social networks, we're creating chat applications, we're creating dashboards, we're creating things that simply weren't really possible back then or much more difficult to create back then. We're also noticing a movement towards a separate code base for our front-end applications from the API server itself. So we have one code base for our React stuff, let's say, and we have another code base for our API server. I mean, sure, you could be using the same code base, but we're seeing a movement towards having separate code bases. We're noticing that the browser URL is now the entry point to our front-end application. And the browser URL is all using HTTP GETs. I mean, when you type in a URL into your browser, hit enter, that's issuing an HTTP GET request to that URL. Then once your JavaScript application is loaded, it's responsible for making AJAX requests to your server. So it's responsible for the get, post, put, patch, delete, all those different HTTP verbs. So since your front-end JavaScript application is only concerned with HTTP GET, very much like how our applications in the 90s were only concerned with HTTP GETs, can we now do routing like it's 1999? And well, the answer is, oh yeah, we can. And this has really been a little pet project of mine since I'd say around 2012. I've been like waiting for the day that I could simplify the router and I could just put files in folders again. And that was my entire structure. I mean, I've been using Rails for a while and I absolutely love Rails, don't get me wrong. But there's a part of me saying, can we just simplify this? Can we just make this easier? Can we just make this better for my team and more direct? I don't want to mentally map URLs in my head anymore. I don't want to have a separate router for my application anymore. I just want to put a file in a folder and I want that file to be served. Can we do that? And well, just last year, the right combination of technologies came together to make that truly viable. And I created a tool called PEGASUS-LOADER. And if you're wondering why I called it Pegasus, because a Pegasus is a pretty sweet delivery mechanism. I mean, would you like to be delivered on a Pegasus? Of course you would. And project structure-based routing is a pretty sweet delivery mechanism for your web apps as well. So that's why I went with the term PEGASUS-LOADER. So what's the deal with this mystical creature? Well, the main purpose of this is to generate routing configuration for you. And it does that for React routers. So if you've used React Router before, you probably had to require React Router, write a bunch of configuration for it, and that will then in turn load all of your components. What I wanted to do was I wanted PEGASUS-LOADER to generate that configuration for me. And if you're not familiar with React Router, it has routable React components, so your URL will literally route directly to a component, which was fantastic. It supports dynamic segments, so that dynamic post ID in my URLs, React Router will support that. There's lifecycle hooks for on-enter events, on-exit events, and so on and so forth, so you can do authentication and, let's say, redirect to a you must sign in page if they're not authorized for that page. You can also handle server-side rendering. So I created PEGASUS-LOADER as a Webpack loader, and basically what it does is it will scan your application for index.js files. And in practice, what it looks like is something like that. So you can simply require Pegasus _dot. And basically what that means is that scan this directory and all of its subdirectories for index.js files and build my routing structure based off of that. One line does literally all of that. You can do this for subdirectories. So let's say you have an app directory and all of your components are in there. You can do /app, and that will then scan app and all of its subdirectories. You can even break off your application into node modules, let's say, and have mountable applications into one main application. So now, as your application grows to hundreds, thousands of components, you can just split them off. and then you can just require each one of them on its own. So what's an example of this? This is what it looks like in code. We can require React, React DOM, React Router, and Pegasus, the routing configuration. So line 4 there, we can see we're scanning this directory and all subdirectories for index.js files and building routing configuration based off of that. React DOM render the router with its routing configuration inside the body. That's it. I haven't had to write any routing configuration at all. That is literally it. So what does our routing structure look like from that? Well, it looks very much similar to 1999. We have the main difference on that page is that we're routing to index.js files instead of index.html files. That's it. For our RESTful resources, that's what it looks like. We have the 2 GET requests. You'll note that the dynamic segment is represented with an @ sign in our file system. File systems don't like colons, so I've used an @ symbol instead. And that @ symbol denotes a dynamic segment in my route. You'll also note that the post, patch, delete, those aren't, we don't care about those. Those are handled by JavaScript AJAX calls. We don't need to worry about those in our routing structure. So this is much simplified over what we've had in Rails or what we've had in PHP with htaccess. It is that simple to do. So what are the benefits of this? Well, there's a direct mapping of your route to your component now. That's great. I don't have to mentally map all these things using htaccess files or routers. It's just what you get on the file system. That is literally your routing structure. That is it. I've entirely eliminated the need for having a separate router. I haven't written any routing configuration at all. It's the same convention across applications. So as I mentioned, you're able to just take your application, split it off as many times as you want, let's say. Let's say someone created an awesome authentication app. You can just pull that in as a node module, mount that, and you're done. It's consistent across applications. Components are grouped by semantic relation to each other. So we don't have a flat project structure where we have a single directory with hundreds of components in it. Everything is grouped based on its relation to each other, based on your routing structure, which, if you've designed your routing structure in a smart way, is based on semantic relation to each other. So your components in your application is now structured in that way naturally. So let's take a look at this. I've taken the subtree of my application, just the posts. This is what it could look like. I have a post directory, a index.js file in there. Inside there, I have a @postid directory, index.js file in there. And I also have an edit directory, index.js file in there. So let's say we want to add a store to this application. Where would we put it? Well, we just put it right where it belongs. It's a post store. All it cares about is posts. We can put that in our post directory. Right? Let's say we want to add a few actions to our Flux app. We can put those in the relevant directories as well. For post ID, we want to get the post. Therefore, the get post action lives in our post ID directory. For the edit directory, we want to save that post. That's a JavaScript action. And we can put that directly in the edit directory. So now our entire application is, again, grouped semantically by function. It's not spread across various directories based on the type of module that it is. So if I was to be, as a developer, if I'm working on posts, all I got to do is load up that directory. And that's it. I don't have to load up several large directories containing hundreds of files. I just pull up that directory, and that's everything I care about if I'm working on posts. So something else that we had in 1999 that we don't really have today, or at least it's a bit difficult to do today, is incremental loading. Front-end JavaScript applications are terrible for loading extremely large payloads over the wire. I mean, it's very common to group your entire JavaScript application and all of its dependencies into one massive 10 megabyte payload and send that over a mobile network or something. It's just so many people are guilty of this. How does PEGASUS-LOADER improve on that? Well, and by extension, how does React Router improve on that, in fact? So all of our server-side applications were incrementally loaded way back in the 90s. And front-end applications have a terrible history of these large payloads, not very good for mobile. So Webpack introduced us to good incremental loading support for the front end. If you're not familiar with Webpack, they have this concept of code splitting, and these code splits define code chunks. I'll get into that a bit more later. React Router has incremental loading hooks for this. So React Router will actually load each and every component separately for you if you use the proper hooks. And with PEGASUS-LOADER, you get all that for free. PEGASUS-LOADER will actually generate React Router configuration with all of those hooks built in. So each and every component in PEGASUS-LOADER is actually loaded on demand. So this is very much like server-side applications of old, or how we did it back in the 90s, where each and every HTML file was loaded individually. That's how it's done with PEGASUS-LOADER as well. And I'd like to, in fact, give you a quick little demo of this. Let me just switch over my stuff here. Bear with me. Mirror displays. There we go. You can all see that. Perfect. And this is our good old TorontoJS site. Yay! Let's open up this good old Chrome debugger. Disable the cache. Let's say we only want the domain to be TorontoJS.com. And let's reload this page. So you can't see that because it's tiny. And let's close this console. Close this thing again. Anyway, there we go. So, okay, we can see we have a few different things being loaded here. This is the main HTML file that's loaded initially. Our bundle.js here is loaded. That's the main bundle for our application. We can see it's kind of large. It's maybe 136 kilobytes. That's loading React, React Router, React DOM, all of our components, a few style. Well, sorry, not all of our components. The main component, the application component, its styles, and a few other things as well. This one bundle.js is loading this route here. So this physical page is one bundle.js. Now, if we go to, let's say, upcoming events, we can see two bundle.js is loaded. So that's about 6 kilobytes gzipped, minified. And what that is loading is it's loading this page here. So it's loading this component, its actions, its stores, everything pertaining to it. Right? So our entire application is loading incrementally as we navigate through it. And I'll give you a quick little TorontoJS.com. I'll show you the code for this. And as I said, you're able to just go to github.com, TorontoJS, TorontoJS.com. You can clone it, you can run it. It's all very simple. And in here, our main entry point is client.js. You can see it's very similar to the example I showed you in my application, React DOM. We have PEGASUS-LOADER right here. And that is literally the entire router. That is it. I haven't written any routing configuration at all. Now, if we take a look at what that translates to in practice, it's going to scan this directory. I have it PEGASUS-LOADER requiring this directory. So this index.js file will be my root component. So if we go to /, it's going to map to /index.js. I know you can hardly see that. Oh, maybe it's a bit better up here. There we go. /index.js. That's where it's mapping to. And as you can see in here, it's rendering that component. If we go to upcoming events, we have the /upcoming events route. That is going to the upcoming events directory. Who would have guessed? The index.js file in there, as you can note up here, that is what's being loaded from that route. And as we can see, this component is responsible for requiring all of our stores, our actions, a nested component, and so on and so forth. So Webpack's smart enough to actually bundle all of that together and load it all at once based on that code split point. So that is how that bundle is being asynchronously loaded in my application, is because I've required those things in my app. And as you can see here, this is responsible for actually rendering that React component further. And I can go on and show you all of the other components, or you can just check this out yourself. It's relatively straightforward. Cool. So, 2016, the year that it is today. I hope I've convinced you that in 2016, you can do routing just like it's 1999. Thank you so much.